Hello everyone, welcome to Group 1's presentation on initiated chemical vapor deposition, or for short, CVD. ICVD was first developed in the early 2000s and is an incredibly potent strategy for coating substrates. It is particularly unique in that it can allow for coating of materials that don't lend themselves to other polymerization techniques. The CVD performs the coating through the following process. First, a mixture of reactant gases, an initiator, and an inert are sent into the reaction chamber where the gas species moves to the substrate. The reactants then get adsorbed on the surface of the substrate, the initiator facilitating in this process. The gases react with the substrate, forming our film. For our experiment, we decided to test the effect of varying the temperature of the substrate chiller and the flow rate of our initiator, TBPO. Consulting the literature, we see that the polymerization reaction has a negative enthalpy of reaction. Because of this, we hypothesized that as the chiller becomes cooler, the faster the coating will occur. We also hypothesized that an increase in the initiator flow rate will result in a faster coating as well. The following four equations were crucial to determining the rate of deposition. An intensity reading is taken through an interferometer, and from the resulting sine wave we are able to calculate deposition rate. In order to validate our results, we calculated the activation energy of each trial to compare to literature values. That's all of the theory. Now we head into the lab. The following table is our results from the CVD. Of 15 trials, 11 were successful. Once again, these trials were spanned across two variables, the amount of initiators sent in and the temperature of the chiller. Let's get into the analysis. When we look at the plot of the inverse of chiller temperature versus the natural log of rate, we don't see much of a trend at all. The confidence intervals of the data all overlap, indicating that the points were perhaps too close to one another, and this could also suggest that there's no true trend. The second plot, which is flow rate of TBPO versus the natural log of rate, is equally as interesting. We see a downward trend, suggesting that as TBPO flow is increased, rate of deposition decreases. This was completely different from what we had hypothesized would happen, but there may be an explanation to this. If TBPO is in excess, maybe it was hindering the deposition by simply just getting in the way. As mentioned before, we also calculated activation energy from our measurements. When comparing these values to those found in previous work, we found that our values were on average about 6 times lower than those found in the literature. Ambiguity in rate units may be to blame for this, but it also may indicate a problem with the machine or our operation of it. Thank you for watching.